Hi everyone, let me introduce myself Pawan Kumar. I have done an internship project named washing machine. Let me introduce to my project. So, the washing machine has a great impact in modern society. The washing machine is a machine that uses to wash various types of clothes without applying any physical efforts. So, the automatic machines may wash, spin, and heat in one cycle. Presently, we can find a variety of washing machines, particularly fully automatic ones, which are front runners in terms of client demand. User enjoy the fully automatic machines, then semi-automatics. We built a simple washing machine spin timer using PIC16F877A. Microcontroller and microprocessor are used to control various electronic operations such as motoring systems and controlling systems and driving systems. During this internship, I have about gained knowledge about C programming and microprocessor and microcontroller. In which C programming, I have learnt about number systems, data representation, data types, operators, arrays, functions, strings, storage class, and pointers. And microcontroller, an, an integrated circuit which is capable of being programmed to perform a specific task. All the components in single chip, less design complexity. The microcontroller can take inputs from devices and they controlling and retain the control by sending devices different signals to the different parts of the device. Microprocessor. The microprocessor contains arithmetic logic and control circuitry required to perform various functions of computer CPU. We need to connect the peripherals externally so to so it makes circuits bulky. Due to the external components, the total power consumption will be high. Therefore, it's not an ideal device for running on storage power like batteries. Needs of microcontroller. It is a integrated circuit that contains a microprocessor along with memory and associated circuits, and that controls some or all the functions on the electronic system or device. A microcontroller is a simple computer on single metal oxide semiconductor integrated circuit chip. An embedded system has a microcontroller unit that has all functional blocks available on same chip. Microcontroller is classified as bits, memory devices, and instruction set. There are 8-bit and 16-bit and 32 bits of microcontroller available, and external and embedded memory devices. And in microcontroller we have two types of instruction set, that is RISC and CISC. The fundamental aspects for selecting the microcontroller like power efficiency, temperature tolerance, hardware architecture, processing power, memory, hardware interface, software architecture, and cost. Like what is embedded systems? Like an embedded system is microcontroller or microprocessor based on the system which is designed to perform a specific task. So its main purpose is to control the device and allow a user to interact with it. It consists of a microcontroller with onboard memory and a power supply and communication ports for transmitting the data to other devices. The type of embedded systems. Embedded systems are classified based on the performance and functional requirements like real-time, standalone, networked, and mobile. Whereas the classification based on the performance of microcontroller, the embedded systems are divided into three types: small scale, medium scale, and sophisticated. The general block diagram of embedded system. Each microcontroller is connected to sensor conditioning and output interfaces. Sensor conditioning, we connect several sensors to perform the task, and output interface is connected to actuator and indicator. and several components of embedded systems like power supply, processor, and timers, serial communication ports, memory, output circuits, system application, and specific circuits. From here, my friend will continue about this project.
Hello everyone, my name is Sheikh Lukman and today I am going to explain our project on washing machine using PIC16F877A. Now we use the tools or software such as MPLAB, XID, XE8 compiler and PICSIMLab which we have downloaded from the browser, and several components I am going to explain such as light emitting diode. Light emitting diode is a semiconductor light source that emits light when current flows through it. White light is obtained by using multiple semiconductors or a layer of light emitting phosphor on the semiconductor device. Simplest device used in most of the applications as feedback. Some applications are home lighting, remote control, surveillance, etc. The basic structure of LED is shown in figure, and LEDs are connected to port B and port D. Port is a peripheral and we need to know how to access and address each of the peripheral. From the section of port B, from the section of port from the section of port B, it is clear that there is one more register associated with it named TRISB. The TRISB register is a very important for input-output configuration. The value of this register would decide pin direction as shown in the below. And now tactile switches. In matrix keypad, we need to configure rows as output and columns as input. A tactile switch allows electricity to flow in an electrical circuit by manually pressing the operating section. The switch activities when pressed and then turns off when released. The tactile basic structure is shown in figure. When the relaxed tactile, over delay, metal looming conductive track and circuit substrate will be present. And when it is pressed, it is as shown. And non-tactile switches, there will be no conductive track and it is attached to the overlay. It is relaxed and other is pressed. And now interrupts. An interrupt is a communication process set up in a microprocessor or microcontroller. Interrupt is a signal emitted by hardware or software when a process or an event needs immediate attention. It alerts the processor to a high priority process requiring interruption of the current working process. The MPU acknowledges the request, processes the request and goes back to position where it was interrupted. There are several interrupts such as instructions as shown in the figure. And next, timers. Timers are used to keep a record of time for different events occurring in embedded systems. Built-in timers are timer 0, timer 1, timer 2. The timers maintains the timing of an operation in sync with a system, clock or an external clock. Some important terms related to timers are tick, resolution, quantum, scaling. The basic timers can be is shown in the figure. And now CLCD. CLCD is nothing but character liquid crystal display. A liquid crystal display is a mode of display used in digital equipment, replacing many other modes of displays such as cathode ray tube, LED displays, and plasma displays. Most of the character LCD module used in embedded system applications. In PICSIMLab, we have two types of displays: 16 into 2 display and 16 by 4 display, as shown in the figure. And now digital keypad. The digital keypads are widely used for input devices being used in various electronics and embedded applications. They are used to take inputs in the form of numbers and alphabets and feed the same into system for further process. And there is the figure for digital keypad. And now PIC16F877A. It is nothing but PIC Genius board from Microchip. It is high performance RISC CPU. It works based on CMOS technology. As said earlier, the built-in timers are timer 0, timer 1, timer 2. It consists of 5 ports, namely port A, port B, port C, port D, and port E. Each port is of specific bits, and we can see that port A is of 6 bit. It is also called as analog port. And port B is of 8 bits. It is a bidirectional port. Port C is of 8 bit and digital pins used for serial communication. Port D is of 8 bit. It is also a digital pins, and port E is of 3 bits. And you can see the basic structure of microcontroller, which is PIC16F877A, and it consists of LCD displays and 7 segment displays, switches and LEDs, buzzers, and a cooling fan, etc., as shown in the figure. And the simplified features of this board is the CPU will be 8-bit PIC and the number of pins will be 40, and the timer module is 8-bit 16-bit. Communication peripherals are UART1, SPI1, I2C, etc. External oscillator will be up to 20 MHz. The CPU speed will be 5 MIPS, and the program memory in KB will be 14 KB. The RAM bytes are 368, data EPROM is 256 bytes. And I am going to explain how we want to show the output in the PIC 16F877A microcontroller. As soon as we power on the device, we want simulator to show a message like powering on washing machine. After powering on, simulator should show all the washing machine modes. Simulator also contain matrix keypad, and with the help of these keys, user will be able to choose respective modes. In this particular design, we included pause button that will pass the time and will turn off the device until it releases it. After completing the event, time up messages will be displayed on the CLCD. And the modes of operation in the washing machine program are daily, heavy, delicates, whites, echo cottons, rinse plus dry, wash only, dry only, stain wash, etc. These modes of operation should be shown by the output. Demo now.
Now I am opening the MPLAB XIDE software. In this we can write the project code. The project name is washing machine and it consists of header files, important files, linker files, source files, and CLCD digital keypads. The header files consist of required files and source files consisting for the required files. In the source files and header files we can write the code. After completion of writing code we have to save, and here is the save option. After saving this code we have to build the main function. To build main function, click on this. Here there is arrow mark and here there is arrow mark. Then we have to select build main function. After clicking this we will get build successful. Here I get the build successful, hence the project was run successfully. Then we will see the output at PIC16F. Now I will open PIC16F. I opened PIC16F. Here we can see the output. After opening we have to select the board. The board is PIC Genius, and the microcontroller is PIC16F877A. And then we have to adjust the clock frequency to 20 MHz. And in this PIC16F board there is LCD. It is in two modes, and one is 16x2 and another one is 16x4, and it is fan, it is buzzer. It can be adjusted by this. These are the switches: RB0, RB1, RB2, RB3, 4, 5, 6, and it is considered as switch 1, this is switch 2, this is switch 3, and RB3 is switch 4, RB4 is switch 5, RB5 is switch 6. These are the keypads and these are the LEDs. These are these LEDs of the port B and port D. Now we can see the output here. So we have to select file, load hex. We have to select project file. Here is washing machine project file. I have selected, then open the file. It displays press key 5 to power on washing machine. Now I am pressing switch 5 to power on the washing machine. It displays the power on washing machine, and after washing program it displays consisting of 11 types of washing programs. To scroll down the screen, we use the switch 4. See, I am pressing the switch 4. Daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua wash. Now I am selecting the heavy. To select the heavy, we have to long press on switch 4. Now I am pressing switch 4. Then it displays water level. Water levels are 5 types: auto, low, medium, high, max. I am selecting auto level. Then I am long clicking the switch 4. Then it displays the press switch. Switch 5 considered as start and switch 6 considered as stop. Now I am starting the program. So I will press switch 5. I am pressing switch 5. Now it displays functions, wash, timer will be on. These are the seconds. And switch 5 for start and switch 6 for pause. It pauses. I am pressing switch 6. And then the fan will be off and the program will be off condition. To resume this program, I have to press switch 5. Now I am pressing switch 5. I am pressing switch 5. And see, the program is executed and it will be in on mode. If I press switch 1, the door is opened. Please close the door. When I resume the switch 1, it continues the process. When we press the switch 6, it pauses the program. To continue the program, we have to press switch 5. See, the program is resumed. The washing machine program will be continued. When we press switch 1, it displays door is opened. Please close the door. When I leave the switch, it displays this. After completing this, it displays program completed. Remove the cloths. Now I am concluding this program. To conclude the washing machine simulator project effectively, met its objective of building an interactive and user-friendly system for operating a washing machine using the PIC16F877A microcontroller. The system enables users to choose different washing modes and water levels, while the display provides real-time updates on the current operation and remaining duration. This project highlights the role of embedded systems in enhancing the usability of household appliances and emphasizes the adaptability and usefulness of microcontroller-based solutions in practical real-world applications. So, thank you for giving us this opportunity, and thank you.